Hi, my name is Ale, and in this video I will be showing you how we can create an app to search for music using the iTunes API. We're going to open Xcode and create a new iOS project. We can select App, and then we can give this a name. I'm gonna name my app Music Search. We should make sure that SwiftUI is selected as the interface and SwiftUI app is selected as the lifecycle. And of course, Swift should be our language. We can press next and we can find a place to save our new project. I'm gonna save it to my desktop. Perfect, so now that we have our project, we can start working on our app. So we're going to start by creating our initial UI for our app. So in our content view.swift file, we're going to make some modifications. I'm first going to create a reusable view that we can use when the user hasn't searched for anything or there are no results. So this will be like our empty state view. So let's create a new struct empty state view, which will be of type view. And here we will need the body, var body, which is a view. And what we'll add here is first a vertical stack or VStack. Inside our VStack, we're going to add first a spacer. Then we're going to add an image, which will have a system name of music.note, music.note. And this image will have a font, which is of system with a size of 85. And it's going to have some padding at the bottom. Now, after our image, we're going to have a text. So let's add text. And the string here will be start searching for music, ... And this text is going to have a font of the title. Finally, we're going to add another spacer to our VStack. Now, we're going to add some padding around our VStack, and we're also going to change the foreground color, and I'm going to use a color created from a UI color. So color dot system indigo. But here you can also choose any color that you want. So great, now we have this empty state view that we're going to show when there are no results or in the initial view of our app. So what we'll do here is we're going to get rid of this text and we're going to embed all the content in our content view in a navigation view. And inside our navigation view, we're going to have a vertical stack. Inside this VStack, we're going to add our empty state view. And we're also going to modify the title in our navigation views. So what we can do is under VStack, we can add .navigation bar title. And the title will be music search. Okay, so let's go ahead and run our app and see how our empty state view looks. Great, so as you can see, we have the navigation bar with the title music search, and we have our empty state view, which has this image of a musical note and the text start searching for music. So now we're going to go back to Xcode and we're going to add first a search bar that will be here at the top that will be used to type any search term. And we will use that search term to find some music using the iTunes API. So let's stop our app and go back to Xcode and add this search bar. So we're going to use a UI search bar, but UI search bar is part of UIKit, so we're going to need a way to embed a UIKit view inside our SwiftUI view. And to do this, we're going to create a subclass of UI view representable. So let's go ahead and add a new structure, struct search bar, which will be a subclass of UI view representable. This is what will allow us to embed our UIKit view inside our SwiftUI view. Now, to conform to UI view representable, we need to add some methods as well as a type alias. So first, let's add our type alias. And this type alias just needs to tell xcode which type of UI view this UI view representable will hold. So this is called UI view type. And the type this representable will hold is a UI search bar. Now we need to conform to some methods. So the first method is called make UI view, func make UI view, which has a context and returns a UI search bar. So let's instantiate our search bar here. Let search bar be equal to UI search bar. And the frame can just be .0. Now we're going to add some modifications to our search bar. So first, we're going to give it a delegate. So search bar dot delegate, and the delegate will be the coordinator of this context, which we will add in a second after implementing the necessary methods here. So the delegate will be the context dot coordinator. Then we're also going to change the style of our search bar. Search bar dot search bar style, which will be minimal. And we're going to add a placeholder. Search bar dot placeholder. This placeholder will be visible when the user hasn't typed anything inside the bar. So we can add something like type a song, artist, or album name. And finally, we're going to return this search bar. Now, the next method that we need to implement is the make coordinator method. So func make coordinator, and this will return the object that, like I said earlier, will act as the delegate for the search bar. So what we're going to do first is add an internal class inside our search bar that will be the coordinator. So class search bar coordinator, and this will be a subclass of NSObject. And like I mentioned earlier, this will be the search bar's delegate, so it needs to conform to the UI search bar delegate. Okay, so now that we have this class, this is the type that our make coordinator method will return. And so what we'll do is we will return a new search bar coordinator. Okay, so now we still aren't conforming to the UI view representable protocol, and that's because we have to add one more method. So this method is func update UI view, and for this tutorial we can just leave this method empty. Great, so now we have our search bar ready, and so we can use this view in our SwiftUI view to add the search bar at the top of our app. So let's go back to our content view, and in our VStack, we're going to add first a search bar. Great, so now let's go ahead and run our app again and see how it looks. Perfect. So as you can see, we now have both our empty state view as well as a new search bar that the user can use to type any term or anything that they want to search. Great. So now let's go back to Xcode and start implementing the data model for our app. Here is where we'll have the different model structures to represent our response from the iTunes API, as well as the methods to make a request to get the data from the API. So let's stop the app and we're going to add a new file, new file. This will be a Swift file, and we can call it data model. And let's create it. Great. So like I mentioned earlier, this is where we'll have our model structures. And so first we're going to see how iTunes returns a response. So the URL that we'll have to build will look something like this. So it's itunes.com/ or itunes.apple.com/search, and we have to provide a term that we want to search for and the type of entity that we want to get from the API. So in our case, we want to get song entities. So let's copy this URL and see how the response looks. So we can open a browser and let's paste this URL here. And so the API gave us a text file, so let's open it. And this is what the response looks like. Now, this is a little bit hard to visualize, so let's just go ahead and copy all this text. And we're going to look for a JSON viewer that we can use to visualize this easier. So JSON viewer. You can just use this first result here. So we'll paste this result that we got, and now we can go to the viewer. So as you can see, the JSON first has a result count, which is 50 in this case, and then it has a list called results. And in this list, we have more dictionaries with each of the results. So let's look at the first one. So each result has some data. So the data that we are going to use is the track ID so that we can identify each result. We're also going to use the artist name, and we're going to use the track name here. And we're also going to use the artwork URL 60. So this is where we'll get the artwork for this song. So now that we know how our data is structured, we can go back to Xcode and add the necessary structures to represent the data from the API. So let's go back to Xcode and let's first add a structure for the whole response. So this will be struct song response, and the response will be decodable because we're going to use a JSON decoder to decode the text that the API gives us. Now, in this response, we're going to have a list of songs because we saw that we're going to have a list of results, each representing a song. So before continuing with the song response, let's add a new structure called song. And this structure will also be decodable. Now, in each song, we're going to have 4 properties. First, the ID, which is an int. Then the track name, which is a string. Then the artist name, which is also a string. And finally, the artwork URL, which is also a string. Now, these names should match what the JSON result gives us, but as you can see, for example, here I'm using artwork URL, but in the response, we're going to have artwork URL 60. So what we can do is add some coding keys to tell Swift that we're going to use artwork URL to map to what should be artwork URL 60 in the JSON response. So to do that, inside our song structure, we're going to add an enum, which is called coding keys. And this will be of type string and also a coding key. And so for each of these four properties, we're going to tell Swift which key it should use. So for ID, the key that we get in the response is actually track ID. So we can go back to the JSON viewer and see that. Now for track name, we actually get track name in the response, so we can leave it as is. Then the same will happen for artist name. But for the artwork URL, we are using a different key, so this should map to artwork URL 60. Perfect. So now that we have a struct to represent each song, what we have to do is continue implementing the song response. So again, if we see our JSON result, we see that the response will have a list called results, and this list will be a list of songs. So in our song response, we can add let songs, which will be a list of song. And again, we're using a custom key. We're calling it songs, but actually in the JSON, we see that it is called results. So we can do something similar like we did for the song structure and add a coding keys enum. So enum coding keys, which is of type string, and coding key. And here we only have one case, which is songs. And this should map to the results key. Great, so now we have structures to represent the full response that iTunes gives us, as well as each of the results in the response. So now inside this same data model file, we're going to add a new class called data model, class data model. And this is where we'll have methods that will send a request to get the data from the API. So in our data model class, we're going to have first a variable, private var data task, which will hold the actual data task, URL session data task, and this will be optional. Now we're going to add a method that will load these songs from the API, and then a helper method that will build the URL based on the search term that the user entered. So let's first add this helper method. Private func build URL. And we have one parameter here. So for term, search term, which is a string, and it will return a URL. And this is optional because if we're not able to build the URL, then we will return nil. So the first thing we're going to do is make sure that the search term is not empty. So guard not search term dot is empty. And if it is, then we're just going to return nil. Now we're going to create a list of query items, and this query item is basically each of the parameters that we pass to the URL. So we're going to have one query item for the term and another one for the entity. So let's create a list called query items. And let's add the first item. So URL query item, the name is term, and the term will be the search term. And then the second item will also be a URL query item with the name entity. And the value here will be song. So this is just what type of entities we want to get in the result of the request. Okay, so now that we have the query items, then we're going to build the URL. So let's create a URL components object. Var components is equal to URL components. And we will build this from a string. Here is where we're going to add the URL. So this will be itunes.apple.com/search. And then we're going to add the query items to the components. So components.query items will be equal to the query items list that we created. And finally, we're going to return the URL that we get from this components object. Return components.url. Great, so we have now this helper method to build the URL based on the search term that the user types. And so now we're going to add the method that actually builds or creates this URL and sends the request. So let's add a function here, func load songs, and we're going to add two parameters to our method. So the first one will be the search term, which is a string, and then we're going to have a completion block that the caller of this method will provide, and this completion block will be called when the request either succeeds or fails. So let's add completion at escaping, and in this method we're going to provide a list of songs, and this method has no return value, so we can just return void. So now that we have our method declaration, let's actually add the implementation. So first, we're going to cancel any task that may have been executing when this method is called. So data task.cancel. And then we're going to first try and create the URL based on this search term. So guard let URL be equal to build URL for term search term. Else, if we're not able to build this URL, then we're going to call the completion block with an empty list, and we're going to return. Now, if we're able to build this URL, then what we're going to do is create a new data task and resume the data task. So data task is equal to URL session dot shared dot data task, and we're going to use this method here with URL, which also has a completion handler with data, response, and error. So the URL we'll use is the URL that we just created, and for the completion handler, we're only going to use the data. We're going to ignore these other values. So what we can do here is add data and then underscore in. And first, what we'll do is check whether we were able to get this data. So let's add guard let data equal to data. Else, if we're not able to get this data from the API, then what we'll do is again call the completion handler with an empty list, and we're going to return. Now, if we're able to get the data, then what we'll do is try to decode it from the JSON format into a song response. And we're going to call the completion handler with the list of songs. So let's add if let song response is equal to try question mark, and here we'll create a JSON decoder, and we're going to call decode. What we want to decode is the data into the song response format. So the type will be song response.self from the data. So if we're able to decode this response, then we're going to call the completion handler, and we're going to pass song response.songs. Perfect. So now that we have our data task, all that we have to do is resume it. So we are going to call data task.resume. Great. So now that we have our data model class and implementation, we're going to add our view model, where we will call this load songs method, and we will return the results to our view to display in the app. We're going to add a new file to hold the view model. So let's add a new Swift file, and we're going to call this song list view model. And we're going to add two classes inside of this file. First, we're going to add a class to represent the view model for a single song, and then we're going to add the class to represent the view model for all of the results of a search. So let's first add class song view model. This view model will be identifiable, and it will also be an observable object. The song view model will have four properties. First, we're going to have the ID, let ID, which is an int. Then we're going to have track name, let track name, which is a string. Then we're going to have the artist name, let artist name, which is also a string. And then we're going to have the artwork, and this will be a published property because when we get the results for each song, we have a URL to get the artwork. So what we'll do is return the results for the songs to our view, and then load the artworks and update the view as these artworks become available. So we will need to publish this change to our song view model. So add published var artwork, and this will be of type image, and it will be optional. We're going to have to import SwiftUI, and when a song view model is initialized, we're going to take in a song model, and we're going to assign our properties based on the data in the model. So init song from a song. And here we can assign our properties. So self.id will be equal to song.id. Self.trackName will be equal to song.trackName. And self.artistName will be equal to song.artistName. Great, so now that we have our song view model, we're going to add the view model to represent all of the results of a call to the API. So we're going to add a new class song list view model, and this will be an observable object. In our song list view model, we're going to have two published properties. One will be the actual search term that the user types onto the search bar. So add published var search term, which is of type string, and initially will be an empty string. And the second published property will be the list of songs or the list of song view models. So add published public private set var songs, which is of type list of song view model, and it will be an empty list to start. We're using public private set because the view will be able to read this list, but it shouldn't be able to modify its contents. And we're also going to have a data model object that we will use to load the data from the API. Private let data model, which is of type data model, and we can just initialize a data model object. Now we're also going to be using combine in this tutorial, but this is by no means a combine tutorial, so I'll link some resources below if you want to learn more about combine. But we're going to use it so that whenever the value of this search term changes from the search bar that is in our content view, so whenever this value changes, we're going to call the load songs method in our data model. So we're going to import combine, and we're going to have to store a set of any cancelable objects. So let's add private var disposables, which will be a set that will hold any cancelable. Now, when we initialize our song view model, we're going to start listening to changes to the value of search term. And whenever its value changes, we're going to call the methods in data model. But before we add the initializer, let's first add a method that will load the songs whenever the search term changes. So this will be private func load songs, and this will have a search term which is of type string. And what we'll do first is empty the list to remove any songs that we had there previously. So songs.remove all. And we're going to call the load songs method of our data model. So data model.load songs, we're going to pass the search term. And for the completion handler, what we're going to do is get this list of songs and append song view models to our songs list. So let's add here our completion handler, songs in. And for each song, we're going to call a method called append song. So let's declare that method. Private func append song, which will take in a song object. And here what we'll do is create a view model. So let song view model be equal to song view model. We pass the song, and then on the main thread we're going to append this new view model to our list of songs. So dispatch queue.main.async self.songs.append song view model. So now if we go back to our load songs method, in our completion block, we're going to call songs.forEach, and then for each song, we're going to call self.append song, and we pass the song object using $0. So now that we have our load songs function, we're going to implement the initializer for our class. So init, and here what we're going to do is set up an observation so that whenever search term changes, we call this load songs method. So we have to use the $sign search term, and we're going to use a method called sync receive value. And so here we receive a value of string, and what we're going to do is call load songs, and the search term will be the receive value. And then we're going to store this new cancelable object inside our disposables set. Store in set, and here we use the and sign and then pass disposables. So now we're going to have an observation set up so that whenever search term changes, we update the song view model list, which will in turn update our content view or the UI of our app. Great, so now that we have our view model set up, we're going to go back to our content view, and we're going to add a property to our content view structure, which will be the song view model. So let's add a new property. This will be an observed object, so we can add observed object var view model, which will be of type song list view model. So now whenever a content view is initialized, we have to give it a view model object. So we're going to have to update anywhere where our content view is initialized to provide this new object. So we'll have to do that inside our preview, song list view model. And we're also going to have to do that in the music_search_app.swift file. So we have to provide here a song list view model. So now we're going to do two things. We're going to set up the UI to show the results we get from the API. And we're also going to make sure that our search bar is connected to our view model, so that whenever the value of the search term changes in the search bar, then the view model gets that change and calls our load songs method whenever it's necessary. So let's first add two reusable views that we will use to show the results that we get from the iTunes API. So let's add first a structure that will be called artwork view. Struct artwork view, which is of type view, and this artwork view will have an image, let image, which is of type image, and this will be optional. And then we're going to add the body section of our view. So here we're going to have first a z-stack, and we're going to check whether our image is nil. So if our image is nil, then we're going to have a placeholder for the artwork. But if it's not nil, then we will show the image in our z-stack. So if image is not equal to nil, then we'll show the image. Else, we're going to show the placeholder. So we're going to show first a color, which will be .system indigo. Then we're going to add an image with a system name of music.note. And this will have a font of large title. And it will also have a foreground color of white. Now for our whole z-stack, we're going to change the frame. So it will have a width of 50 and a height of 50. It will also have a shadow with a radius of 5, and it will have some padding on the trailing side, which will be of 5. Perfect. So now that we have the artwork view, we're going to create the song view. So let's add a new structure, struct song view, and this will be a view. Our song view will need one song view model. So we have add observed object var song, which is of type song view model. And then we're going to add the body of our song view. So in the body, we're going to have a horizontal stack or H stack. And inside our H stack, we're going to add first the artwork view. So artwork view, and the artwork view needs an image. So this will be song.artwork. And we'll also add some more padding. So dot padding, and this will be on the trailing side. Then we're going to add a vertical stack or V stack. And in this V stack, we're going to show the song's name as well as the artist name. So we're going to add first text, and here we'll show song.track name. And then we'll also add another text, and here we will add song.artist name. And for the artist name, we're going to change the font, which will be footnote. And we're also going to change the foreground color, which will be gray. Now we're also going to add some padding around the whole of the horizontal stack. Great, so now that we have our view set up, we're going to go back to our main content view and make some modifications. So first, what we're going to do is get rid of this empty state view that we show all the time. And we're only going to show it whenever the list of songs in our view model is empty. So instead of always showing our empty state view, what we're going to do is check if view model.songs.is empty. So if there are no results, then this is when we will want to show the empty state view. Otherwise, we want to show a list with all the results. So else, we're going to show list that will have view model.songs, and for each song in. So for each song, we're going to add a song view, which will need this view model. And we're also going to modify the style of the list. So the list will have a list style of plain list style. Perfect. So now we have all of our views set up, and the final thing we have to do, like I mentioned earlier, is to connect the search term in our view model to our search bar so that our search term in the view model is correctly updated. So what we're going to do is we're going to modify the search bar so that it's initialized with a binding to a string, which will be the search term. So let's add a new property to our search bar at binding var search term, which will be of type string. So our search bar will be initialized with this binding. And then we're also going to have a binding in our coordinator. So let's, we can copy and paste this binding. And we're going to have to add an initializer to our search bar coordinator. So let's add init search term, which is a binding to a string. And we have to provide the initial and we have to assign this new search term property. So self dot underscore search term. To initialize a binding, we have to provide the underscore. And this will be equal to the value that we get in the initializer search term. So now when we create a search bar coordinator, we have to pass the search term. Since it's a binding, we use the $sign search term. And we're also going to have to update the initialization of our search bars, since now we have to provide the binding to a string. And so our search bar will be bound to the viewmodels search term that we defined earlier. It's here, it's a published property. So we have to use $sign viewmodel.search term. Perfect. So now all that's left to do is to make sure that the search term is updated when the string in the search bar changes. So we're going to add a UI search bar delegate method that will allow us to know that the user entered a string in the search bar. So func search bar search button clicked. So when the user presses search, what we're going to do is update the search term. So search term will be equal to the text in the search bar. So search bar dot text. And since this is optional, we have to provide a default value of an empty string. When the user presses search, we're also going to dismiss the keyboard, and we can do this by using UI application. So UI application dot shared dot windows, and we're going to find the first key window. So dot first $0 dot is key window, and we're going to call end editing, and we're going to force it, so we pass true here. Perfect. So now our search bar has a binding to a search term, and the binding that we're providing is the search term in the view model. Now in our view model, when the value of the search term changes, then we're going to call the load songs method, and we're going to get the songs from the API. Now, when we get the response from the API, we're going to update our list of songs with new song view model objects. And since our view uses this list of songs in our view model, it will update itself to either show the results using song view or an empty state view if the list of songs is empty. So let's go ahead and run our app again. So initially we have the empty view because our list of songs in the view model is empty. So let's type something into the search bar, Taylor Swift, and let's press search. And so as you can see, we have a list and we have a list of results. Now, there are two things happening. First, the artwork is showing the default view, and that's because we haven't actually downloaded the artworks to show in our list of results. And also the alignment in our text seems a bit off. So we're going to make some updates to our UI code as well to make sure that this alignment is updated. Okay, so let's go back to Xcode, and we're going to go to our song view. And in our vertical stack, we're going to add the alignment parameter, alignment, and the alignment will be the leading. So let's run our app again to make sure that our results are shown correctly. So we can type something else here, Coldplay, and let's press search. Okay, perfect. So as you can see, we now have our text correctly aligned in our view. So now all that's left to do is to load the artworks to show in our list of results. So let's go back to Xcode, and we're going to add a new file called artwork loader that will be in charge of downloading the artwork. So let's add file, new file. This will be a Swift file, and I'll call it artwork loader. Perfect. And so here we're going to define a new class artwork loader. Inside this class, we're going to have a list of data tasks because we're going to be downloading several images. So we're going to store each task in a list. So let's add private var data task, which will be a list of URL session data task. And initially it will be empty. Now we're going to have a function called load artwork, and this will take in a song model as well as a completion block that will be called whenever the image is downloaded. So func load artwork for song, which is of type song, and the completion handler. So this will be at escaping. This will be a function that first takes in an image, which will be optional and has no return value, so it can return void. Now, since we're using image, we have to import SwiftUI. So first, what we're going to do is try to build the URL for the artwork. So guard let image URL is equal to URL, and we will create it from a string. Remember that we have the artwork URL property in the song model. So song.artwork URL. Now, if we're not able to create this URL, then we will call our completion handler with nil, and we will return. Now, what we're going to do is create a new data task if we're able to create the URL. And we're going to append this data task to our list and then resume it so that we can download the image. So let data task be equal to URL session dot shared dot data task. And this will be with a URL and a completion handler. So the URL is the image URL. And for the completion handler, we're only going to use the data. So we can add data underscore in. And first, we're going to make sure that we were able to get the data for the image. So guard let data be equal to data. And then let's try to create a UI image from this data. Let artwork be equal to UI image from the data. Else, if we're not able to get the data or if we're not able to create the UI image, then we're going to again call the completion handler with nil, and we will return. Otherwise, we're going to create an image object. Let image be equal to image from a UI image. So we will pass the artwork here. And we will call our completion block with this newly created image. Now, what we're going to do is call data tasks dot append, and we will append this new task. And then we're going to send the request, so we can call data task dot resume. Perfect. We're also going to add a a public function that will cancel all of the tasks, and we will call this function whenever a new search term is given to our view model, so that if we were downloading images for a previous term, then we can cancel those tasks and send the new task. So let's add here func called reset. And all we'll do here is data tasks dot for each. And for each data task, all we'll do is call cancel. So $0 dot cancel. Perfect. So now that we have our artwork loader, we're going to go back to our view model and we're going to create a new artwork loader. So private let artwork loader, which is of type artwork loader. And we will create a new instance. And we're going to do two things. First, whenever load songs is called, since we're resetting the UI by clearing the songs list, and we're also going to call artwork loader dot reset. And now what we'll do is that whenever we append a new song view model to our list, we're going to load its artwork so that we can show it in our UI. So what we'll do is call artwork loader dot load artwork for song, and we can pass the song model. And in the completion handler, we're going to get an image. So let's add image in. And again, on the main thread, we're going to update the song view model with the new artwork image. So dispatch queue dot main dot async, and here we will call song view model dot artwork is equal to this image that we downloaded. Okay, so now let's go ahead and run our app again and see if we can now get the artwork for each song in the results. So let's type a search term here. I'll type Shawn Mendes, and then I'm gonna press search. And great, as you can see, we now have the results, and each result also has the artwork for the song. Now let's try and search for something different and see if we're able to get updated results. So I'll type Bieber and press search. And as you can see, our results list is updated with new songs. Great, so that's all I wanted to show you in this tutorial. I really hope you enjoyed it and you learned something new. If you want to learn more about iOS development with Swift and SwiftUI, make sure that you subscribe to my channel as I'll be posting new videos very soon.